Sanbonani Abafundi, welcome back. We're continuing with our study of prime factors, and today we're going to look at all the reasons why we prime factorize numbers, why it's a useful skill to know. Right, let's dive straight in. The first thing we're going to do is just prime factorize a couple of numbers. So this is question 33 on page 39, and I generally prefer the tree method. I just think it's slightly quicker. So 300 is 30 times 10. 10 is not prime, but it's 2 times 5, both of which are prime. 30 is not prime, but it's 3 times 15, and it's not 3 times 15, it's 2 times 15. And 15 is not prime, but it's 5 times 3, 3 times 5, both of which are prime. Okay, so 300 is actually 2 squared, 2 2's, 1, 2, times 3, only 1, 3, and 2 5's, 1 there and 1 there. Right, so we've kind of got all our bits and pieces. Right, let's do 480. 480 I think is quite straightforward because it's just 48 times 10. Remember 10 is 2 times 5, so we get better and better at this as we go. 48 is actually 4 times 12. If you've learned your 12 times table, then that's fairly straightforward. 4 is not prime, but it's 2 times 2. To save space, I'm just going to write that as 2 squared. 12 is 4 times 3. Now 4 we know is 2 squared as well, times 3. So there we've got it all done quite kind of efficiently. Let's count how many, sorry guys, I've put circles around some of these things which shouldn't be there. As you know, I only like to put the prime numbers in circles, right? So I'm going to take that out, and this, if I just put it back, this was 4 and 12, right? So the prime numbers, we've actually got 1, 2, 3, 4, 5 2's, and then we've got a 3, and then we've got a 5. And that is 480. Okay, sorry, not very neat, but hopefully you're neater than I am. Okay, let's now look at 4 great reasons to prime factorize. So when we prime factorize a number, it's actually like writing it in, it's kind of finding out what makes up that number, what its building blocks are. All right, okay, so let's just quickly prime factorize these numbers. Now, with practice, one gets better and better, but 24 is 8 times 3. 3 is prime, 8 is not, but 8 is actually 2 cubed. So 24 is 2 cubed times 3. 28 is 2 squared, it's 4 times 7. And 300 is 2 squared times 3 times 5 squared. Okay, now, the only reason I can do those in my head is because I've had loads of practice, okay? But remember, 100 is 4 times 25, and there's the 3. Okay, now, if we were to think about numbers that divide into these numbers, we're currently busy with looking at finding the highest common factor. So we want a number that will divide into those numbers. Now, if we look at it, it can have 2's in it. Our number can have 2's in it as a base when it's prime factorized, because all of these have got 2's in. So 2 will be a common factor. Okay? All right. Now, let's look at 3's. A number which has got a 3 in will divide into this number and into this number, but not into 28. So we cannot include 3. We also can't include 5. Because 5's not in this one, and we also can't include 7. So what we do is we write down any bases that occur in all the numbers, all right? And now, we want the highest common factor. Now, unfortunately, we can't go with 2 to the 3. 2 to the 3 would work fine here, but it wouldn't divide into there because that one's only got 2 2's. So we've actually now got to take the smallest number that's in common, and we've got 2 2's there. And that is our highest common factor. All right. So we've kind of done this in one step here, or in one line. But what we do is we write down all the bases, and then we give each base the lowest power that occurs. So here we've got a base of a power of 3, a power of 2, and a power of 2. So we go with the power of 2. Okay, let's practice a couple. We're going to pause the video and ask you to try it's question 34, and then we will let it run again and see how you went. Okay, so the first thing we've got to do is prime factorize these numbers, okay? And again, I'm going to do this reasonably quickly, all right? 200, okay? Remember 100 is 2 squared times 5 squared, all right? It's 4 times 25. That's 100. We've got 200. So 200 is actually 2 cubed times 5 squared. Okay, doesn't matter if you needed to draw a tree to do that, all right? 300, remember 100 is 2 squared times 5 squared. So 300 is going to be 2 squared times 5 squared times by 3. Okay, and 4800, now we've just done 480. All right, I know we haven't, somewhere, yes. We did 480 over here, right? Okay, but 4800 is going to be, if we look at 480, it's going to be that multiplied by 10. So in fact, it's going to have an extra 2 and an extra 5. It's going to be 2 to the 6 times 3 times 5 squared. 2 to the 6 times 3 times 5 squared. That's 4,800, 4,800. I'm going to pause and just check that on a calculator, just to remind you that that is possible. Right, so remember what we do. We just, if we're lucky enough to have one of these calculators with the fact button on it, all right, we just press 4,800 equals, and then we go shift fact. All right, and then we see it's 2 to the 6 times 3 times 5 squared. Okay, I'm trusting that you now are comfortable with prime factorizing and that you could get all of these, even if it took you a little bit longer than it took me. Sometimes in a question we will prime factorize it for you, like in number 35. Let's now turn our attention to how we find the highest common factor, and let's really concentrate on why this works, why it makes sense. It always makes sense. Maths always makes sense. Okay, what bases are common to all three numbers? Yeah, that's right. 2 is and 5 is. Okay, we could not have a 3, a number which has a prime factor of 3 in it, as the highest common factor, because it would not divide. We can see that 3 is not going to divide into that number. 2 will divide into that number, and so will 5. Now, when we're finding the highest common factor, we can't go with the highest number of 2's, because 2 to the 6, there are not 6 2's in there. All right, even 2 to the 3 would be a problem, because we couldn't divide 2 to the 3 into this number. There are only 2 2's. So what we do is we take the lowest number of each. So we take the lowest number of 2's, which is 2. All of them have got 2 5's, so the lowest number of 5's is 2 as well. And that is our highest common factor. Our highest common factor, if we multiply it out, is actually 4 times 25, it's 100. 100 goes into all of those numbers, and I think you can see that 100 will go into all of those numbers. But the important thing is that there's no bigger number that goes into all of them. Okay, just to recap what we do, we prime factorize first, then we write down only those bases that occur in all the numbers, and then we take the smaller number of each that occurs. Okay, pause the video, try number 35, and then let it run again and see how you did. Okay, so let's take a look. We've got these two numbers, quite large numbers, and they've been prime factorized for us. Okay, now, again, let's just think about what the highest common factor needs to look like. Well, it can only be made up of 2's and 3's and 5's. Although there's 7's in this number, there are no 7's in that number, so we can't write down 7's. Okay. Now, you might think, oh, we're finding the highest common factor. Let's take the highest number of each. But in fact, if we took, say, 2 to the 3, 2 to the 3 would divide in here. We can see that. Okay, no problem. However, 2 to the 3 would not divide in here. So, so we need to take the smallest number of each. Okay, So the smallest number of 2's is 2. The smallest number of 3's is also 2. And the smallest number of 5's is just 1 5. Okay, so in fact the highest common factor is actually going to be 4 times 9, which is 36, times 5, which is 180. Okay, but if you don't multiply it out, that's not a train smash. We need you to be able to think about how to find an HCF. Okay, next up we're going to look at the LCM. And it's a similar idea. We're going to start off by prime factorizing the numbers. All right, 24 is 8 times 3. It's 2 cubed times 3. 27 is 4 times 7. So it's actually 2 squared times 7. Remember, we can't leave it as 4. 4 is not prime. And 150, all right, 150 is actually 3 lots of 50. But 50 is 2 lots of 25. And 5 is 5. Sorry, 25 is 5 squared. So there's 150. Okay, now what we're going to do this time, right? Because we want numbers that these numbers will divide into. All right. And in order, let's just think about that. In order for a number to create a number that all of these are going to divide into, we need to have 2's and 3's and 5's and 7's. Because if we don't have, for example, if we leave off the 7's, then this number will not divide in. Okay, we won't have a multiple. Now, we want the lowest common multiple. Okay, the first number that they will all divide into. Now, we can't, if we're choosing our bases, our powers rather, we can't say, well, let's just have 2 here, because 2 to the 3 won't divide into it. So in fact, for the lowest common multiple, we choose the highest of each. So 2 to the 3, 3 to the 1 is only, okay, 5 occurs twice, so we've got to have 2 5's, and 7 occurs once. Right, this is, if we had to multiply this number out, we could work it out, okay, but basically it's, yeah, it's 24 times 5, which is 120 times 5, which is 600. I think it's 4,200. Okay, I'm less worried about that than about us knowing how to do this process. So now let's just quickly remind ourselves the difference, okay? With the HCF, we only write down the bases that are common to all the numbers, and we take the lowest of each. With the LCM, the lowest common multiple, we write down all the bases that occur across all the numbers, and we take the highest of each. Okay, right. We're going to ask you to pause the video. We're going to ask you to try number 36 and number 37. Okay, so what I've done while the video is paused is I've prime factorized those numbers. 200 and 300 were from the previous page. 350 is just 35 times 10. All right, but remember 10 is a 2 times a 5. Okay, and a 35 is a 5 times a 7. So we've got a 2 5's and a 7. Let's turn our attention now to actually finding the LCM, which is the important part here. All right, we need to have 2's. All right, all these numbers have got 2's in them. We need to have 3's. Now you might say, Paul, this one hasn't got 3's in and this one hasn't got 3's in, but this one has. In order to create a number that this number is going to divide into, we need to have some 3's. And then we also need to have some 5's because they've actually all got 5's. And we need to have a 7 because some 7's, because this number will not divide into our result if we don't have 7's. We are trying to create a multiple. Okay, so let's have a look. If we only have 1 2, or even 2 2's, this is going to be a problem. 200 won't be able to divide into our multiple. It won't be a multiple. So we actually need to take the highest number of 2's that occur. We need to take the highest number of 3's that occur. They've all got 2 5's, so we need to take 2 5's, and we need a 7. If we multiply all of this out, okay, that's 8, that's 25. 8 25's is 200. That's 21. It's actually 4,200. The more you use your brain, the better it gets, okay? I'm not too fussed about your multiplying that out, but I need you to understand how we get that. All right, let's look at how you went on number 37. This one, like before, has been prime factorized for us. So we're trying to create a multiple, a number that both of these numbers will go into. It therefore needs to have 2s, 3s, 5s, and 7s. Okay, but if we only have 2 2s, then this number will divide into it, but this one won't. We need to have 3 2s in order for this one to divide it. Let's think of the same thing about the 3s. In order for them both to divide in, we need 3 3s. In order for them both to divide in, we don't just need 1 5, we need 2 5s. So we're taking the higher number in each case. And for 7, we need 7 squared. I'm not going to multiply that out, I'm going to leave it there. That brings us to the end of the lesson, but let's just quickly recap the difference, okay, between the two processes. Highest common factor, only the bases that are common to both numbers, or all the numbers, because we can have more than one number, all right, more than 2 numbers. And then for the highest common factor, we actually take the lowest number of each base that we've chosen. For the lowest common multiple, we put all the bases that existed across the numbers, and we take the highest number. So we sort of do the opposite. For the highest common factor, we take the lowest number of each, and for the lowest common multiple, we take the highest number of each. It will get easier with practice, as all maths does. All right, looking forward to seeing you next time.